Welcome to the OpenShift Service Mesh demo. OpenShift Service Mesh is based on the upstream Istio project, but with OpenShift we add to it, particularly in the areas of traffic visualization. You'll see one such component in today's demo, Kiali, for Service Mesh topology visualization. As you can see, I'm logged into my OpenShift cluster as administrator, but both on the terminal and web interfaces. We use Kubernetes Operators to install the Service Mesh. Provisioning of operators requires admin access, though consumption of operators, typically by developers, does not. For speed, I'll use the same admin user for both provisioning and use. Okay, let's get started. So to install Service Mesh, we need to install 4 operators from the OpenShift Operator Hub. That is Elasticsearch, Jaeger for distributed tracing, Kiali for Service Mesh topology visualization, which we'll see later, and they are supporting the 4th operator, the main one, the Red Hat Service Mesh operator. What I'm going to do is I'm going to install those 4 operators from the Operator Hub. As I have a slow internet connection, I'm going to just open up 4 tabs to allow me to do that faster. So the first one that I'm going to do is Elasticsearch. And select that Elasticsearch operator, and I'm going to choose all namespaces on the cluster with automatic approval. I'm going to do that with each of my 4 operators. This next one is going to be the Jaeger distributed tracing operator. And I'm going to choose the Red Hat one. Again, all namespaces with automatic approval. Third one I'm going to choose is Kiali. Same as before. And then the 4th operator is the Service Mesh operator itself. So after a few minutes, my operators have installed, as you can see on the screen. Next I'm going to create a Service Mesh from the Service Mesh operator here. Earlier I created a project or a namespace called Istio System, which I've selected here, and I'm going to install my Service Mesh within my Istio System namespace. So the first thing I do, I get a choice of a service member role or a Service Mesh control plane. First thing is a control plane. I select that. I get a number of tunables that I can modify if I want, but I'm going to go with the defaults. So I create that, and in a moment that will be ready. After a short time, my application is installed, and I can verify it on screen here in my pods view under my Istio system namespace. I can see all of my containers are running and ready. I can also verify that by running the OC-get pods, and we can see that everything is ready. So now I'm ready to apply my Service Mesh control to my microservices application. I'm going to use the sample book info application that's available from the upstream Istio website. Here's a diagram of the application. It's a very basic application, a web page called product page. On the left hand side of the screen will be displayed the results of the details page here. But of most interest to us are the 3 microservices, reviews microservices, the results of which will be shown on the right hand side. When version 1 of reviews is called, ratings is not called and no stars are shown. When version 2 of reviews is called, ratings is called and black stars are shown. And when version 3 of reviews is called ratings, is also called with red stars shown. So as we apply control, this visual representation makes it easy to see what's happening. There's three things we need to do. First is create a namespace for our book info application, and we're just going to call this book info. We can do this either on the GUI or on the command line, but I'm just going to do it here on the command line. The next step is to create a service mesh member role. That was the other item that the operator can create that you saw earlier. It essentially dictates which namespaces I'm going to apply service mesh control to. So I go to my install operators and I choose my service mesh and I create a new service mesh member role. Of most interest here is just the members, the member projects. I'm just going to enter book info. So that will just begin to create now. And the final thing that I need to do at this stage is to install my book info microservices application, which my service mesh member role is going to look at and apply control to. So I'll do that by applying some YAML that installs the book info microservices application we just saw a diagram of. So on seeing this creation, the service mesh member role will apply service mesh control to the application that's inside the book info namespace. So I simply do that by applying this YAML here from the Istio upstream website. And that's going to take a few minutes now, so I'm going to pause. A couple of minutes later, our book info microservices application is installed with service mesh control applied to it. As you can see here, all of the components, the details, product page, ratings, reviews, etc. are deployed, running and ready. So the next thing we need to do is set up some service mesh constructs that are inherited from upstream Istio for service mesh member control. First is to apply the envoy based sidecar proxies and the microservices to apply to them. Again, we'll just apply some YAML that's from the Istio upstream site. Next, an Istio gateway representing the port and the protocol at the ingress point to the mesh. In our case, HTTP and port 80. So we'll apply those. And next, the Istio destination rules. That is addressable services and their versions. So next we're going to do is export the gateway URL from the Istio system so we can actually hit our web page. You can see that's shown here. I'm going to hit that and I'm going to append the path product page. This is the URL that we'll use throughout. If we refresh this page several times, we could see that it just loops through the reviews microservices versions, showing black stars, no stars, and red stars in a sort of a round robin fashion, indicating there's actually no Istio control being applied. Let's move to our Istio system networking routes view and open up the Kiali route there. This is our topology visualization tool, and we get the option to log in using our OpenShift credentials. So we supply those. So now we're logged into Kiali. We've selected our graph view on our book info namespace, showing the request percentages going to each of our microservices and their versions. We're displaying animation, traffic animation, as you can see, and we're showing the view for the last 5 minutes. Now we can start to apply traffic control. So first we're going to do is apply version 1 of everything. We do this with a virtual service, which defines a set of traffic routing rules to apply whenever a host is addressed, including the service version. So in our case, version 1 of all services. Let's go ahead and do this by applying the following YAML here. And if we hit the web page following the creation of that virtual service, we'll see of most interest the fact that now only version 1 of the reviews with no stars is ever going to be displayed. Now if we switch across to Kiali, eventually this view will update to show 100% going to version 1 of everything, and in particular version 1 of our reviews. So let's pause the recording until that happens. With the process, I've changed my view to be the last minute so I don't have to wait for 5 minutes. You can see that version 1 is now serving out the traffic exclusively, also reflected in Kiali. Next thing what I'd like to do is to demonstrate how Service Mesh can distinguish individual users in its routing decisions. This can be useful for Canary releases where we only want to release a particular version to a particular group of users. So what I'm going to do is I'm going to log in as user Jason, and once logged in, after I apply my next virtual service, he'll only see version 2 with black stars. All others will see version 3 with red stars. So first of all, let's go ahead and apply that particular virtual service, and I'm going to log in as Jason on my web page here. So JSON, the rules specifies that JSON only ever sees version 2, and all other users or a logged out user will see version 3 with red stars. And we can see Kiali has reflected to show approximately half going to version 2 and version 3. Now let's say we're happy with version 3 and we want to roll it out to 100% of all traffic. So let's go ahead and do that also with a virtual service. Now if I refresh my page, I'll see that version 3 is exclusively serving out traffic. And if I switch across to Kiali, when it updates in a moment, yeah, right now you can see that it's again serving out 100% of traffic. Finally, I'd like to demonstrate another feature of Service Mesh, fault injection. Netflix famously have a chaos monkey that randomly just kills nodes and applications. In Service Mesh we can do this also to ensure that your system recovers from faults gracefully. Let's apply a fault injection on our details microservice to always return an error, a HTTP status of 555. You'll recall that the details microservice is the one that's serving out the left hand side of the screen here. So we go ahead and apply this rule here. Now if we refresh our page, you can see we always get an error back from the details microservice here on the left, and our application is gracefully dealing with this error scenario. If we switch across to Kiali, in a moment it should update with the latest error condition coming back from my detailed microservice, and indeed you can see that we get a red coming back from details, and we get an orange coloring around product page indicating that part of its constituent services are error returning, and part of it is the reviews part is returning fine. So this has been a demo on installing and using OpenShift Service Mesh based on the upstream Istio project. We've only scratched the surface on what's possible, but hopefully you can get a glimpse of its powerful traffic control and visualization capabilities. Finally, I'd like to just direct you to my GitHub repo, TNS Corcoran OpenShift-Service Mesh, where all the instructions and the commands, etc. for running today's demo yourself will be found. So it just walks through the entire demo here, making it easy for you to run yourself. Thanks.